Hey guys, welcome to today's Bellringer. I'm going to follow a similar procedure to how I did Monday's Bellringer. I'm going to do all these problems except for the line plot. Tomorrow's video, posted in the Thursday folder, will have the solution for the line plot for you to watch. So if you would prefer to save the line plot problem for Thursday, you're welcome to do that. Okay, let's go ahead and work on our exponents review. We're going to calculate 23 and 5/10 times 10 to the power of 2. Now, the order of operations tells us that we need to solve this part of our expression first, because we always need to do exponents first. 10 to the power of 2 has a value of 100. So we're going to be solving 23 and 5/10 times 100. 23 and 5/10 times 100 means that we're going to be moving our decimal point over 2 spots, 1, 2. So we're going to move our decimal point over 2 spots. Remember the really embarrassing way I taught you to remember that? They're little baby butt cheeks, aren't they adorable? So that gives us a product of 2,350 for this problem. Okay, next we're going to work on our measurement problem. We're going to convert 12 gallons to some number of quarts. Now, a gallon is bigger than a quart. Think of a gallon as being like a really big milk bottle looking shape. This is not going to be the best drawing ever, but it's the best I can do. That's a gallon, 1 gallon. Okay, and then a quart is 1/4 the size of a gallon. So there's 4 of these quarts. There's 4 quarts in a gallon. So if I were to duplicate, let's see here. Let me make 4 of these. Okay, so here's my 4 quarts for 1 gallon, which means I would have 8 quarts for 2 gallons, which means I would have 12 quarts for 3 gallons, and I don't have time to do all this repeated addition. So instead of doing 4 quarts, 8 quarts, 12 quarts, I'm just going to take my 12 gallons times 4 quarts in a gallon, and that will give me 48 quarts. Okay, this is a perfectly acceptable way to solve it if you have a lot of free time on your hands. If you're a busy person like me, it's probably easier to multiply. Okay, now we're going to convert 5 pounds to some number of ounces. Now, a pound, think of a pound as being like something kind of heavy that you would pick up and move around at the gym for exercise. This is supposed to be a pound weight. And ounces are smaller than pounds. An ounce is like what you weigh babies in. They're little itty bitty, little. There's 16 ounces in a pound. So that's a case of horse to fly, multiply. We're going to take our 5 pounds and we're going to multiply it times 16 ounces in a pound. So 5 times 10 gives me 50, and 5 times 6 gives me 30, so that's a total of 80 ounces. OZ stands for ounces, so this should be 80. Okay, now remember, I need to see your written work to go with these problems. Don't just give me answers. Okay, we're going to change 23 and 1/6 to an improper fraction. Now I'm going to show you the fastest, most efficient way to do this, and I'll be curious for you to tell me if this makes sense to you or not. 23 wholes. We're going to represent that in terms of one hole that's been cut into 6 equal pieces, and then we're going to duplicate that 23 times. 3, 4, 5, 6, 7, 8, 9, 10. Haha, just kidding. We're not going to do that. That would not be efficient at all. Miss Lynn is so silly. Look, that's a group of 10 6, 6, or 66. Whoops, 66. Yeah. Now, nobody has time for that, my friends. I don't have time to draw all those models. So instead, I'm going to multiply my 23 holes times the 6, 6 that compose each hole. So that's this 23 times. Let's see what that's going to give us. 23 times 6. That gives us 138 sixths plus one more 6, because I can't forget this guy, and that gives me 139 sixths. Okay, so I'll be curious if this makes sense to you. We're going to calculate the area of a figure that has a length of 10.5 centimeters, or 10 5/10 centimeters, a width of, whoa, I drew that kind of opposite, didn't I? Let me swap those around because that's going to bother me. Okay, I'm going to call this, oh gosh, I'm all messed up. Hang on. I'm sorry. Let me try to make this make sense. Okay, length, 10.5 centimeters. Width, 8 centimeters. And height, 3.5 centimeters. Okay. Now the formula for volume is to multiply length times width times height. So I'm going to multiply 10.5 times 8 times 3.5. And in order to do that, I'm going to have to come over here. Where should my decimal point go? I've got one place value position here. I've got another one here. So for each digit that I have to the right of my decimal point, I have to have a matching digit to the right of my decimal point in my answer. So that gives me 56 and 75 hundredths. Then I have to take that number and multiply it by 8. 56 and 75 hundredths times 8. Okay, so I'm getting a volume of 454 cubic centimeters. I will not give you credit for this problem unless I see your written work showing how you did the multiplication. Just a word to the wise. We're going to subtract 3 4/5 minus 7/8. In order to subtract this, I need to find the least common multiple for 5 and 8. And I can already tell it's going to be bigger than what I gave myself space for. So you need to list the multiples of 5 and 8. Okay, 40 is the smallest multiple that 5 and 8 both have in common. So I need to convert 3 4/5 to 3 and some number out of 40. The way I'm going to do that is by multiplying my numerator and my denominator times 8. 5 times 8 is 40, so that's my denominator, and then my numerator will be 32. Then I'm going to convert 7/8 to some number out of 40 by multiplying my numerator and my denominator times 5. That will give me 35 out of 40. Now I need to subtract. Okay, imagine that on a number line, you have the space in between each whole number divided into 40 equal pieces. That's what I'm showing here on my number line. Now, if I want to mark where 3 and 32 out of 40 is on my number line, I'm going to be right about here. 3 and 32 out of 40. If I hop backwards 32 out of 40 pieces, I'm going to land right at 3. So that would be like taking my 35 out of 40 and breaking it up into 32 out of 40 plus 3 more out of 40. Then I'm going to take 3 more little itty bitty hops backwards. 1, 2, 3. Where does that put me at? That puts me at 3 and 37 out of 40. No, sorry, that puts me at 2, my bad, 2 and 37 out of 40. Let's look at that another way using a visual model. I'm going to show 3 wholes, 1, 2, 3, and then a 4th. And each one, let's see, so the first 3 holes are going to be entirely filled with color because that's going to be my 3 holes, of course. And then I'm going to take this 4th one and I'm going to cut it into 40 equal pieces, which is kind of crazy. Okay, so that's what that looks like. Let me just make sure. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Yeah, that's 40 equal pieces. Okay, so I have 3 and 32 out of 40 to work with. So I need to shade in 32 of these pieces. So that's 8, 16, 24, 25, 26, 27, 28, 29, 30, 31, and 32. Okay, so that's what 3 and 32 out of 40 look like. And now I'm going to subtract 35 out of 40 of those pieces. And you can see when you look at this model, I only have 32 to subtract. So I'm going to need to start cutting into this one in order to fully subtract my 35 pieces that I need to take away. So this is what I'm going to do. I'm going to cross out 32 pieces. This is gone. 32 out of 40. And then here's 33 gone, 34, and 35. So I have crossed out my 35 out of 40. What does that leave me? 1 hole, 2 holes, 1, 2, and then this portion is what is left. And that is, let's see, 8, 8, 16, 24, 32, 33, 34, 35, 36, and 37. 2, and 37 out of 40 is what I have left.